Yeah, good day. My name is Naftali Dwe. I'm a mining engineer. So today I'm gonna be doing a tutorial on Datamine Studio UG. So these are just the essentials. So I'm not going to follow through the tutorial files for the training. For the tutorial files for the training, you're going to do that on your own, and I'm going to be guiding you through. So this one is just an essential training, a basic training that you can just follow through for the meantime while you wait for the other recordings. So you open your software. So the software is loading. So you click on new project if you want to start a new project. If you want to open an existing project, you just click on open project. Then you go to the directory where your project is saved. But your most recent projects are just displayed just below on the open project bar. So you go to the new project bar. Then you click next. So if you have any other modifications that you want to do on the project settings, you just go on project settings. But if there's nothing that you want to do on the project settings, so you click next. So there you have to rename. So I have an existing project which is already called project 1, so I cannot save my current project as project 1, so we have to rename that as tutorial 1. Next, so if you have files, any specific files that you have that you want to use for this tutorial, you click add files. So for this tutorial I just want to maybe use a specific file for the old board which you're going to use for the design. So I go to the direction where my files are. Then I just click the all board with Datamine file. I selected it. So then I click next, then I click finish. So I'm not going to be discussing the user interface. We're going to go through the user interface through the presentations which you were sent to on the group. So the first thing that I'm going to do, I'm going to go to the project files here. Then I expand the all files bar to load the all body wireframe. So I drag and drop the all body TR file, which is the wireframe. Then the PT file is the point file. It displays points for the all body. Then I click here on sheets to remove the grid so that I can clearly visualize my all body. So let's say you're given an all body, then you want to design a specific design that you want to come up with. So for this tutorial, we're going to do a basic Roman pillar design from scratch using files or Datamine files that you're going to create on your own. Let's say you don't have any existing files to start a project. You have to create everything from scratch, just given the all body from the geology department. So this is what we're going to do. let's say just want to create a Roman pillar for this section which I'm going to digitize. Let me just digitize the section that I want to use for the Roman pillar. Let's say this is just the section that we want to design a Roman pillar for, right? Let's say this is just the section for the whole body that we're given, that we want to design the Roman pillar for. So this one is the boundary. So this string now becomes the string boundary for your what? For your whole design. So I'm going to left click on the screen, then I'm going to save this string as the design boundary. As the design boundary, then I'm going to save this file. So that file is already saved. So then maybe there's no need for me to keep this file. Then I go to data and I'll click unload. I'll just click on data, then I just click on unload. I just want to unload the new string, then I click OK. It has been unloaded. So for this section, I'm going to start by creating the main road drives. I want to come up with a Roman pillar with dimensions of 6 meters wide road and 8 meters of pillar. So the first thing that I'm going to do, I'm going to create a string that is 140 meters long for the road. So in order to create that string, I type the command CRS. This is the quickest way of doing things. You have to learn how to use commands. So I want my design to start from here to this point. So I just right click there, then I set the parameters. The azimuth is 0, which means it's going in the north direction. It's going to start from here to here, and it's a straight line, not a what? A radius. Then the length, I just want a string that is 140 meters long only. It's just a small section that I want to design for. Then I click add. I think the string is already loaded. Let me expand the wireframe and remove the wireframe. So this string that is created there is 140 meters long. This string is 140 meters long. So what I'm going to do for this string, I'm now going to subdivide this string into equal segments of 14 meters. So what do I do when I want to subdivide this into equal segments of 14 meters? I type the command IBL on the screen. You just type it, then you click the starting point, then you click the end point of the string. Then you want to segment the length in by 14 by a distance of 14 meters. Then you click OK. Then the string, you can even visualize here that it has been divided into segments that are 14 meters long. So I just want to give this string a color. What do? I go to design, then I click edit, then I go to color, then I give it a color, maybe color 9. I apply, then click OK. So this string has been given a color 9, which is red. So what I'm going to do now, I'm now going to create a string that is perpendicular to this road, that is going to mark the pillars. So what do? I type again the command CRS, then click the starting point, then I set the azimuth as 270 because I want the string to be at 90 degrees with this road that we've already created. So the string maybe is going to be, let's say, it's going to be 200 meters long. It's going to be 200 meters long. Then I click add. It has been added. Close. Then I give this string a color. Let's say it is a color. The shortest way, another easiest way of giving your string a color is just to go to color here. We double click here. then you give it a color, maybe a color green, so it already has a color green. So I'm now going to offset or expand these strings by an equal segment of 14 meters. So what do? I type the command exp, so I'll expand this string by an offset of 14 meters. I want to expand this string by an offset of 14 meters, 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 14 meters. Then I want to offset this one again by 14 meters. So this one is called the manual design 2. You can do it by an automated design 2. So we already have our pillars here, then these one are our rooms. So these strings are marking the rooms, then those boxes are marking the pillars. So these strings that we have created are called FXS files. FXS files. We have also CXS files, then we have what we call complex solids, then files that we call wireframes, then files that we call outlines. So they are different design files, but these general strings, they are just called FX files. They are just called string what? They are just called string files. So now we have our files. Now we have our string file. For the design, what do? I just want to type escape just to remove that cursor on the mouse. I've typed escape. So I want to select everything here. I want to save this file as a single file. So I right click, I select all, then I right click, then I select everything like this, then I left click on the mouse, I right click on the mouse, then click on save selected strings. So I want to save the selected strings as room and pillar outlines. So this is what we do for each and every design that you're going to be working with. Then I save. So it is already saved here on the project files. So this one is your design file. So if you try and rotate this, you're going to see that some of the strings, they are already what? Offset. You were designing this on plan, but some of these strings, they are already offset. So you need these strings to be aligned with what? With the shape of the whole body. So what do? First of all, we have to remove any duplicate files if there are duplicate files on this on this design. Then the second thing that we're going to do, we're now going to project this string onto the whole body. Then from there, we now process our design, giving it the naming conventions, the design dimensions. Then we edit the dependencies. Then maybe export it to the EPS. So I'm going to put it black on plan. So I use this cursor for visualization of my design. So this is what I'm going to do. Since I have already saved my data, let me just cross check if I have saved it. I saved it here as room and pillar outlines. It was not outlines, it was just supposed to be FXS files. So I'm going to unload this file, then check, then run, check it to check duplicate file. So how do I run check it? I come here on the find command, then I just type check it. So check it, yes, check it, then I click check it, then I run check it. So then I have to input the files that I want to check for duplicate files. Then I go there, I find my file, room and pillar outline, and I click OK. Then what is the name of the output of the files that are cleaned, the clean files that are removed that have been removed, that is removed the duplicate files. So the duplicate files are inside the room and pillar outlines that we have designed. So we want to remove those duplicate files. So then we have to save the new file with a different with a different name. So let me save it as new FXS room and pillar. then I click OK, then I go to the sheets bar, then I just remove the grid. I really don't want working with the grid. So the duplicate files have been removed, so I go to the project file. So the new FX Roman pillar has been created, so I drag and drop this. So there are no duplicate files on this tree. So what do? I just want to create a simple wireframe for an all body that actually fits a Roman pillar. So the all body that that we used initially doesn't fit for a Roman pillar. So I just want to quickly digitize and design a solid for an all body that suits a Roman pillar model. So what do? I come here, I just want to unload this data. Let me load it. Sorry, I didn't want to unload it. Let me go to sheets here. I have removed the grid. Then I want to quickly digitize. So if you want to quickly digitize, you can just type NS on the screen. So then you can digitize a new string, or you go to new string. So let's say this is the boundary. Let's assume this is the boundary. Let's say this is the boundary for your whole body. Let's say this is the boundary for your whole body. Let's say this is the boundary for your whole body. I was just assuming this is the boundary for your whole body. So let me right click and save it. I selected string boundary for all body. We save this boundary for all body. We save the boundary for all body, so there's no need for us to keep this file. So I'll just erase it because I've already created it. So I can just erase it. I'll left click, then type erase selected string. Yes, so I just erased it. So then there's no need for me to keep this file. I'll just unload it because I still need it. Unload it. Then I go to the project files. Then I drag and drop my file that I've created called the design boundary. So that is this one is another design boundary that we have created. We want this one called the all body boundary. We want the one called the all body boundary. So let me unload this. I want this one called the boundary for the all body. So this one sheets. So I've unloaded this. So I want to change this into a wireframe that suits the all body that we want. So I go to design. Then solids. I go to solids. Then just click end link. I want to end link this file. So the file is already a flat surface that suits a Roman pillar design is being created. So what do? I left click, then click save. What do I want to save? I want to save the wireframe. What is the name of the wireframe? It's called the all body for a room and pillar. So I saved this all body for a room and pillar. I've saved it. All body for a room and pillar. It's just a flat surface. So since I have already saved it, I'll just unload it because I still don't need it. So what's the next thing? The next thing is to go to the planning window. Then you activate the planning window by clicking the show button. Then you go to design file. Then you click add. You want to add a fixed cross section file. A fixed cross section file, that means an FXS file that we have created. Those strings that we created that marks the outline of our design for the Roman pillar are called the FXS files. So I will just select FXS file for the Roman pillar. This one, new Roman pillar FX file. And I have clicked it. It has been loaded. So what do? I save. Then I go to design. Then I load my design. So this one design has been loaded. So the next thing, what do? I go to, so I just want to work with manual design and automated design. So what do I do here? I come here to automated design rules, then I create a new rule, maybe just called, let's call it Asha, or whatever the name that you want to give your design. So what do I want to do first? The first thing that I want to do, I want to project these strings to the wireframe. That's the first thing that I want to do, project wireframe. So what is the filter file? You input the filter file, the design type. This design type is an FXS file. Then you go to settings, you set your settings here. So first of all, I select the wireframe, all body, room and pillar, what. I've selected it. Then the projection plane is in the XY direction. Then you click OK. Right? I've clicked OK. So let me just set something here. You come here. So I apply. I just had to fix the name of my automated design rules. Click OK here. Then come back here. Select my automated design rule that I've set here. So this one is used to set the design rules. Then here you select the automated design rules that you want to use. Then I click apply. Okay, so just after the moment you click apply, the processing for the design rules here will just appear. So you click OK to process. So you can actually see and visualize that the design is being projected to the wireframe, but it has already been trimmed. It has already been trimmed to the It has already been trimmed to the wireframe. But there's no problem. I'll just save this. I will use the next tutorial just to explain something here. But for the meantime, we just progress. We save there. We go to the design definitions. You add there your design file. So this one is your design file. So all these files, there are 22 files, the design count. So I come here, design definitions. I generate the design definitions. So I click here the name of my file that I'm using for the design. So the name of the file that I'm using for the design is called new FXS room and pillar. I click open. So the design definitions have been generated. So what is the description? What is the name of the red? So the red, they are the rooms. And so don't go to road 1, then road 2. You went in another direction. You're green, you're red. You just type maybe R2. There's no problem. So then I create here default shapes for these rooms. So these are rooms or rows, almost one and the same thing. Almost one and the same thing. New shape. So notice shape for the rooms, and shape for the rooms. I give it the width. It's a rectangle. I give it the width. What is the width? They say the width is we said we wanted 6 meters of rod and 8 meters of pillar. So I'll click 6 meters here. Then the height, let's give it a provisional height of maybe about 3 meters, right? Maybe or 2.4 or whatever height that you want to give. You click apply, you click OK here. Then you come here on shape. You come there on shape. You now select the shape that you've created here. Select the shape here. Select the shape here. You click apply. Then you click OK. So the design definitions have been have been created here. So what you do, the next thing is to validate your design. You process for validation. So the design is valid here. So now you go to process. You now process your design into solids. So you can actually see that your design has been processed into into solids. So sorry about this here. So it said processing failed is due to some maybe network issues. So then I'll go to dependencies. Then I'll load my design. Let me remove this default grid. So you can actually now visualize your room and pillar. So this is how you come up with a simple design for a room and pillar model. So you've changed this into solids so you can visualize. So there's no need for you to design the pillars, since we assume that we are not going to mine those pillars, they're just going to be left out. So there's no need for you to design pillars, so you only design them, the detail that is going to be actually extracted or depleted. So the next thing that you're going to do, there are other factors that we didn't factor into our design. We're supposed to maybe to interrogate this design against the block model. There are other more things that I will actually maybe include on this next tutorial. So this one was just a basic tutorial of how to start your own design from scratch. So this is how you start a design from scratch, and I've explained the essentials of the whole mine planning for Datamine Studio UG. So these are our dependencies. So at the dependencies window, dependence just means things that depend on each other, right? So on dependence, this is where you create your dependencies for your schedule. Which thing goes first, and how all the detail on your design are what depend on each other or are linked to each other. You are just linking or you are just sequencing your design. So you just come here, maybe you want to draw a continuous, which means continuous, you're just linking everything continuously. So let me put it back on plan. So here it is on plan. Let's say you're going to start to mine this one, then 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 this one. You're done. We're going to link the other detail. You're going to start to mine this, maybe this one, maybe this one, maybe this one, maybe this one, this one, this one, and finally this one. Right? You've linked everything. You've created dependencies for your schedule. What you do, you save those dependencies. You go to EPS. You transfer your schedule to what? To EPS. You click transfer for you to transfer your schedule to what? To EPS. We just want to visualize a simple, quick mine plan, design, and scheduling. So the process of sequencing, how we are going to mine everything, is called what? The planning. Then the scheduling, you just link your software, you just link your project to EPS. So the design, we've explained the design process. So we load our solids, we load our points, we load our dependencies, we load our outlines, then we load our schedule. So you can actually see at the bottom of the screen, the EPS window has just been updated there. So this is how our schedule looks like. So you can quickly see how these tasks depend to each other. You can quickly see how these tasks are linked, right? I've linked those red rooms. So I can also link these tasks here, but that's not today's business. I was just explaining how you can do a quick mine plan and design. All right, so let me close this schedule. Let me just save it, then close it. Then I go back to my design. So if I remove these solids, you can actually visualize this paper line. So this paper line is the dependence layer. It just it shows how all these detail, like all those rooms that are in green, are linked. So I can actually do maybe another dependence layer for the detail that is for the rooms that are in green color. So the empty space here, these boxes, they represent they represent the pillars. The pillars are not going to be mined, so they are just left undesigned. So thank you. So see you next on the next tutorial. So I'll actually plan in detail what the next tutorial will cover. But the next tutorial will cover everything, starting from maybe block model creation or body creation, starting your design from scratch, setting your interrogation rules and other details that needs to be set there to come up with a more accurate a design that sums up everything. Yeah, thank you for the tutorial. So you also need to find time to practice. You can also utilize this tool there on the far right corner. Click here, Studio UG tutorial, so you can actually follow through the tutorials. So also the software is on its own, has other files, there are other project files that you can actually use to practice, and you also utilize the files that I have sent you. So this is how you close your software after you finished your design. First of all, you deactivate here the planning window, click here, close. So close, you save your tutorial 1. So the software is closing. So then I click here to close the software. I finally close the software. So we are done.